Alright, good afternoon, Algebra 2 Trig Honor students. So this one is for Chapter 7, Rational Functions. So we'll take a look at that. And let's start it with the graphing part first. So we're going to divide it into three portions of the chapter. So the graphing and simplifying rational expressions, complex fractions, and then solving rational equations. Okay, so we'll take a look at that with the rational functions, the graphing. Okay, so for number 2. So anytime that we deal with the rational functions, not only we want to find out the whole, vertical asymptotes, x-intercept, horizontal asymptote, the domain. But also, you need to do something with the constructions, the structure of the functions. So the structure of the function for the rational function is always considered y equals a over x minus h plus k. And normally, the parent graph is always like this. Okay. So what does that involve here? Is that VA and HA. So the VA is always the value of H, and the horizontal asymptote is always the value of K. Okay. So now compare and contrast. So let's find out the value of A, H, and K. So the value of A here will be considered -4. Again, A just it's a scale factor. It tells you whether that's stretching, shrinking. And again, the value of A, if that's negative, so that means, for the function, is considered reflected over the x-axis. So the value of H, so for this one, we do have H equals 0, because that H is not shown, so that means always 0. And then K, it's always, well, for this one, it's the separated constant, so then that'd be what? 1. So start off with that VA, so VA, which is the y-axis, because that x equals 0. And then k equals 1, then that'd be y equals 1. The horizontal asymptote. So now once we come up with this, we want to set up the xy table to get some points. Easy number. Another thing that you might be considered finding out, it's the x-intercept. So let's find the x-intercept here. So for the x-intercept, so that means y equals 0. So set y equals 0, so we do have -4 over x plus 1. So solve for x. Subtract 1 both sides. So for x here, so that means x is what? +4. So 4 comma 0. So 4 comma 0, which is over here. Another thing that you want to find out, well, there's no y-intercept here because that's the VA. So that it's the vertical asymptote. So you might want to set up some points. So we need to know that part of the graph is like going this way, increasing. The other part of the graph looks like it's going to be like this, because due to the reflection. So let's say that we want to put in -2 and see what happened. So -2, so -4 over -2, then that'd be 2. 2 plus 1, then that'd be 3. -2 comma 3. And let's get another point here, somewhere that's close to the asymptotes. So what about -4? So -4 over -4, that's 1. 1 plus 1, then that's 2. -4 comma 2. So since we found the x-intercept here already, so let's get another point. So somewhere that's close to the VA. So let's say that we want to put in 1. So -4 over 1, then that's -4. -4 plus 1, -3. So 1 comma -3. So once we get those dots, guess what? Simply just connect them. As you can see that the graph here is increasing, but be careful of the tail. The tail is getting closer to the asymptote here, and then the other one is getting closer to the vertical asymptote. So similarly for the other one, so the tail here is getting close to the VA, and the other tail here is getting closer to the horizontal asymptote. Again, for those you might be wondering, well, how come the graph doesn't match with the parent graph? Because that the negative sign, the reflection. So anytime they see that negative f of x, it's always considered the reflections over the x-axis. If you see anything like f of -x, so that'd be the reflections over the y-axis. Okay, so gotta be careful with this. So we find that VA, HA, well, there's no hull. We'll talk about the hull for the next couple problem. And then x-intercept, we found it. And also we sketched the graph already. So now the domain. Now let's find the domain, the range. So the domain for this one, so that means it's negative infinity to 0. And union, 0 to infinity. And then for the range here, so this one is negative infinity all the way to 1, union, 1 to infinity. Okay, so number 4, that one is quite similar. So instead of doing that one, so the next one I would like to show you is number 6. So you might be wondering the structure, it's a little bit different compared to the one we have, a over x minus h, quantity, and then plus k. So in order to find out this kind of form or the formation, so we want to put in either the long division or the synthetic division. So according to the synthetic division, we do know that the numerator is the dividend. So we do have 1, negative 2. Divisor, which is the denominator, so then that'd be 1. Because once you divide it, you'll find out the quotient, you'll find out the remainder. So the first number, bring it down. 1 times 1, that's 1. Plus negative 2, then that's negative 1. So we write it. So this one, we do have 1 minus, or 1 plus negative 1 over x minus 1. Again, the quotient goes first, and then the remainder over the divisor. So that means for f of x, it can be written as 1 plus negative 1 all over x minus 1. If you just swap those terms, we do have negative 1 over x plus 1, minus 1, and then plus 1. So again, identifying the value of a, h, and k. So we do have a equals negative 1. Again, reflected over the x-axis because that's negative. It's a normal curve. And then h is 1. And then k, which is 1 also. So started with VA. So h equals 1. And then the horizontal asymptote, k equals 1. And also we want to set up some points. XY table once again. So this one is quite similar to number 2, the one that I was talking about earlier. Okay, so XY table, let's find a y-intercept. Well, we can find the xy-intercept for this one here. So let's find a y-intercept first. So set x equals 0. So plugging 0, we do have 0 minus 1, negative 1. Negative 1 over negative 1, then that's 1. 1 plus 1, then that's 2. So 0, 2. And then for the x-intercept, so we want to set y equals 0. So set y equals 0, we do have 0 equals negative 1 over x minus 1 plus 1. Subtract 1 both sides, so we do have negative 1 equals negative 1 over x minus 1. And then this one just cross multiplies, so we do have negative 1 over negative 1, then that'd be 1. So x minus 1 equals 1, so that means x equals 2. So 2, 0. Again, the things that the point, we need to get 2 more positions. So this one, I would like to find out something that's getting close to the asymptote here on the left hand side, or the negative region, or the second quadrant. So let's say that we want to put in negative 2. Okay, so let's plug in negative 2 and see what happens. So plug in negative 2, so we do have negative 2 minus 1, then that'd be negative 3. So negative 1 over negative 3, then that'd be 1/3. 1/3 plus 1, 1 and 1/3. Okay, so 1 and 1/3. And negative 2. So 1.33333. Getting close to the horizontal asymptote. And then also somewhere over here, so let's say 4. So 4 minus 1, that's 3. So negative 1 over 3 plus 1. Then that'd be 2/3. So 4, 2/3. Again, it's very close to the asymptote. And all you need to do, just connect the dots. Okay, this one too. Simply just connect them. So they're both considered increasing curve. And then the domain and the range. So the domain for this one, so that'll be negative infinity all the way to 1. And then union 1 to infinity. And then the range, negative infinity to 1. And then 1 to infinity. Okay? So now, what happens if the structure is getting a little bit complicated? So how do we deal with things such as number 8? So as you can see that the previous one, the power, it's always 1. See that top and the bottom? The power here, 1. And then the previous one, the power here is 1. And the power here, it's what? 0. Well, what happens if we see like a quadratic expression top and the bottom? So how do we deal with the rational functions like this? So the way to find out VA, another way to find out VA for the horizontal, for finding VA for the rational function. So the way to do it, you just want to set the denominator equals 0. Okay, so set denominator equals 0. And then from there, we can just solve for x. So we do have 3x squared equals 9. And then divided by 3 both sides. Square root both sides. So that means x is what? Plus minus 3. So plus minus root 3, excuse me. So plus minus root 3, what is that about? It's like 1 point something. So plus minus root 3, so 1 point something. So that would be somewhere here. Whoops, that's point something. Okay, it's a VA. So once you find out VA, well, what else can we do? We can find the horizontal asymptote. Now, the way that you want to analyze the horizontal asymptote is that about the leading coefficient. If that's the same power top and the bottom, the same highest power top and the bottom, so we just want to take out the leading coefficient. And then that would be the horizontal asymptote, the value of k. So which is 1 over negative 3, which is negative 1/3. So negative 1/3, so that's somewhere down here. Okay, so let me just enlarge this. Oops. Okay, so now, once we find VA, HA, and let's see what else that we can find out. The XY intercept. So for those you might be wondering, how do we find the XY intercept for the complex, for the complicated rational function? Again, it's the same process. To get the x-intercept, you want to set y equals 0. Now the thing is that the denominator cannot be 0. In order to set y equals 0, so that means the numerator got to be 0. So for the y-intercept, so this time we need to set the numerator equals 0. So that means x squared plus 2x minus 8 equals 0. It doesn't matter what kind of number that you have for the denominator, as long as we do have 0 over any number down the bottom. So eventually, so y would be 0. So set the numerator equals 0, and then we try to factor it. So we do have x minus 4. X plus 4, and then x minus 2. So that means x equals negative 4, x equals 2. So negative 4 comma 0. Again, very close to the asymptote. And the other one is what? X equals 2. X equals 2, so that would be the point right here. Okay, so once we get those two positions, the x-intercept, and now we want to find the y-intercept. Wait, let's see. No, the way to find the x-intercept, we set y equals 0. Yeah. So we set the numerator equals 0. But now for the y-intercept, sorry. So we want to set x equals 0. So plug in 0 for everything here. So we got 0, 0, minus 8 over 0. So that doesn't work. Okay? So that doesn't work. Oh, you know what? For the x-intercept, I actually did it wrong. Sorry. Let's do it over again. For the finding the VA. I apologize for that. HA is right. The XY table, it's right. But for the VA, forgot about the variable. Being careless. Okay, so for that VA, so you want to set negative 3x squared plus 9x equals 0. Again, set the denominator equals 0. Before you solve for x, you want to take out x first. So take out x and also take out negative 3. So we do have x minus 3. So that means the VA is what? X equals 0 and then x equals 3. So let me just cross out the, erase out the original VA that I put in here. Okay, so again, if you just miss something here, everything else just collapse for the VA. So gotta be very careful. Okay, so for the VA, so we do have x equals 0. So that's why this one we cannot find the y-intercept. Because that the x-axis, the y-axis, it's all covered by the VA. And then x equals 3, the line right here, that's another VA. So now we found the x-intercept. Okay, so now the next thing that you want to find out is about the point, the xy table. So let's continue with the xy table. So we do know that the graph here is getting close to like this, increasing curve. But we need to find out the graph here in the middle and the graph here on the right hand side. Okay. So let's find out something that's getting close to 0 from the right. So let's say that we want to put in 1. So once you plug in the number here, so another thing you might be considered doing, so probably just factor it. So once you put in that f of x to the factor form, so that one is written as y equals x plus 4 times x minus 2 all over negative 3x times x minus 3. So plug in 1 here, so we do have 1 plus 4, then that'd be 5. 1 minus 2, then that's negative 1. And then negative 3 times 1, then that'd be negative 3. And then 1 minus 3, then that'd be negative 2. So this one is negative 5 over 6. Negative 5 over positive 6. So negative 5, 6. So somewhere down here. Now, for those you might be wondering, the horizontal asymptote, is that like going through all over the place here? Now, gotta be careful with that, the middle part of the graph here. So the horizontal asymptote does not apply for the middle part of the graph. Again, horizontal asymptote, it shows the end behavior. So as x goes to infinity, so y goes to negative 1/3. As x goes to negative infinity, y also goes to negative 1/3. So this part of the graph here, so in the middle, so there's no horizontal asymptote. So we just want to get rid of that. And now we got 1 point here, so that means this part of the graph is going this way. I mean, you can get another point if you want to. So let's say that you want to find out what happened here at negative 1. Okay. So in order to be a little bit more precise, so let's put in another x value. So negative 1, so negative 1 plus 4, then that'd be 3. Negative 1 minus 2, negative 3, all over Negative 3 times negative 1. Negative 3 times negative 1, then that'd be 3. And then negative 1 minus 3, then that would be considered negative 4. 3 and 3 got canceled. And we do have negative 3/4. Okay, wait a minute. So it looks like we probably... Oh, you know what? It's this one's supposed to be negative 3. Okay, so hang on a second. So let's check that. Plug in negative 1. So negative 1 plus 4, then that's 3. Negative 1 minus 2, negative 3. And negative 3 times negative 1, then that's 3. Negative 1 minus 3, negative 4. Again, 3 and 3 got canceled, then that'll be negative 3/4. Yep, so this one got to be a little bit more precise. So negative 3/4. So that's going to be all the way down here. Okay, so gotta be careful with that, the point we put in for this, okay? Okay, so now let's see what happened on either side right here. So we found the horizontal asymptote, which is considered negative 1/3. The one down here. So negative 3/4 should be the one down here then. Okay, we'll check the x-intercept once again. Negative 3/4. Okay, so now anything that's over here, so let's say that we want to put in 3. No, 3 doesn't work. Okay, so what about 4? So 4 plus 4, then that's 8. 4 minus 2, then that's 2. Negative 3 times 4, negative 12. 4 minus 3, then that's 1. And then this one, just reduce it. So by 4, by 2, well, by 4 first. So this one turns out to be 2. This one turns out to be negative 3. So it's 4 over negative 3. So 4 over negative 3, that's negative 1 and 1/3. So negative 1 and 1/3. That's somewhere over here. So one thing I just want to check for the x-intercept. Making sure that we're doing it correctly. Yeah, probably the point that I plug in for negative 1 is wrong. Yeah, this one's supposed to be negative 1 and 3 over 4. Negative over negative, that's positive. Yeah. So 3 over 4, then that'll be up here. So once you connect the dots, so one is above the horizontal asymptote, so this one is increasing. And the other part of the graph here, the one in the middle, again, the HA doesn't apply the middle part of the graph. So this one is kind of like a cubic curve. And then the rest of this, increasing also. Like that. So finding the domain, the range. So the domain for this one, as you can see that we do have 1, 2, 3, 3 different interval. So we do have negative infinity all the way to 0, union 0 to 3, because that's the VA, and then union 3 to infinity. Now what about the range? Negative infinity all the way to negative 1/3, and then negative 1/3 all the way to infinity. Okay, so now what about for number 10? So number 10, this one is showing that the degree on the top is greater than the degree down the bottom. Guys see that, the end behavior power. So the highest power term. So the way to find out the VA, so it's just the same thing as what we did for the previous one. So set the denominator equals 0. But the thing is that this one, there's no HA. The reason why that is because that x to the power of 3, the power, it's greater than the power in the denominator. So that's why this one, there's no HA. But the thing is that we can always perform the long division for this to find out the slant asymptote. The slant asymptote, this one is something new. So if there's no horizontal asymptote, that means there's a slant asymptote. Okay, so we'll look at that. So set the denominator equals 0 first. So take out 4. So we do have x squared plus x minus 2 equals 0. So that means it's considered 4 times the quantity of x plus 2 times the quantity of x minus 1 equals 0. So x equals negative 2, x equals 1. So negative 2 and 1 for the VA. And then the other one here, x equals 1. And now what about the slant asymptote? The way to do it, so you want to divide the dividend by the divisor, long division. So this one we cannot use the synthetic division. We talk about that in chapter 3. Synthetic division, that means the divisor got to be considered a linear binomial, but this one is not linear, it's a quadratic, and also it's not binomial, it's a trinomial. Okay, so divide it. And for those you might be wondering, can I just get rid of that 4 first? I mean, you can do that, but let's just put it in this way. So in order to satisfy that x to the power of 1/3, so I multiply everything by 1/4x. So 1/4x times 4x squared, so that would give you x cubed. 1/4x times 4x, that would give you x squared. And then 1/4x times negative 8, that would give you negative 2x. And then all you need to do, just subtract. So x to the power of 3 minus x to the power of 3, this one got cancelled. Negative x squared minus x squared, then that would be negative 2x squared. And then another thing that we have here, this one is what? 0. So we do have a trinomial, but this one's a monomial. Guess what? Just carry down to 0, the 0 term. So again, in order to get rid of that negative 2x squared, so this one, we just want to multiply that by negative 1/2. So negative 1/2 times 4x squared, then that will give you negative 2x squared. Negative 1/2 times 4x, so that will give you negative 2x. And then negative 1/2 times negative 8, then that'll give you positive 4. Final remainder, let's see what that is. So then that'll be 2x minus 4. It doesn't matter what kind of remainder that you have once you finished all the way down like this. So the quotient, this one, it's always considered the slant asymptote. And as you can see that it's a straight line if that's a slant asymptote. So 1/2, so the y-intercept here is 1/2. 1/4, so up 1, 4 over to the right. Or it could be from here, down 1, 4 over to the left. Down 1, 4 over to the left. Slant asymptote. So basically just connect those dots. Again, this one is dotted, not solid, because that's just an asymptote. So once you find the VA, the slant asymptote, so basically we just need to get some points. Again, so to find the y-intercept, so the way to get the y-intercept, you want to set the xy table. So set y equals 0. Okay, so just want to clear all this. Try to get some space. So we want to find the xy intercept and some other points on the graph right here. So once we get the trends for those points, and then we just connect them. Okay, so xy table, so start out with the y-intercept. Well, doesn't matter. So start out with the y-intercept, so set x equals 0. So 0, 0, 0, divided by everything out, -8, then that'd be what, 0? Okay, so that's also the y-intercept. And now, what about the other x-intercept that we can find here? So set y equals 0. Remember, we can always set the numerator equals 0. So x to the power of 3 minus x squared minus 2x set equal to 0. So take out x. So we do have x squared minus x minus 1. Minus 2, excuse me. And then you want to factor it. So x equals 0, we found it already. But this one here, x minus 2, x plus 1. So that means x could be 2, it could be -1. Besides 0, 0, we do have 2, 0. We do have -1, 0. Okay, so now let's try to get some points. So 2, 0, -1, 0. More xy table. So let's try to get some point here for the graph and see how the graph is behave, whether that's going this way or going down this way. Okay, so let's say that if I plug in -4. Now certainly you don't want to plug in a number like this. Very difficult to evaluate. So what you want to do, you want to factor the rational function here, top and the bottom. So once you factored it, the numerator, so we just did that, which is what? X times x minus 2, and then x plus 1, all over denominator. So this one we factor it, so this one is 4 times x plus 2 and x minus 1. Now for those you might be wondering where the hole is, well, this one so far there's no hole, but you see, like top and the bottom, they both come up with x plus 1, x plus 1. That means we can cancel them out. That means at x equals -1, so there's a hole. But this one is not the same kind of factor, so there's no hole here. So plug in -4, so we got -4 times -4 minus 2, -6. -4 plus 1, -3. All over. So 4 times -4 plus 2, -2. -4 minus 1, -5. Okay, so reduce 4 and 4. And then -2 goes into -6 3 times. So now what we got here is -1 times 3, so -3. -3 times -3, 9. So 9 over -5, which is -9 over 5. So it's -1 and 4/5. So it's -1.8. So a -4 is -1.8. -1, -1.8, somewhere here. So now it looks like the graph, we can just put it in to okay, so this looks like we can connect this. So it's going to be like this, and the other part of the graph is going to be like going down this way. Okay, one thing I'm just checking here is that the x-intercept, if that's 2, 0, that means the other part of the graph is going to be like this. Okay, so let's just connect it. Again, the asymptote just tells you that it's getting closer and closer to those positions. Okay, so for this one, 0, 0. And then -1, 0. Kind of like this. And then the rest of this, Well, the thing is that I'm just wondering about this point. This point should be somewhere up here. But let me check that. Excuse me. 2, 0. So that means everything's underneath that the slant asymptote. Does that make sense? Another thing that you can check, you can always plug in the functions to decimal and then just sketch the graph there and see what happened. Okay, so one thing I'm just wondering about this position here. Okay, so let's check that on the decimal and see what happened. This one is one of the craziest one. Normally for the power on the top, if that's higher than the power on the bottom, usually we don't do that until we get into pre-calc. But right now, just want to give you the early introductions. So just want to give you the heads up what's happening. So for that one, so let's see. Okay, x cubed minus x squared minus 2x. Let's do this. Oh, you know what? Try to split it. Cannot. So y equals quantity x cubed minus x squared. Okay, let's see what else. Minus 2x divided by 4x squared. Not yet. Okay, let's see what else. Plus 4x minus 8. So one thing that I messed up here is about the graph here in between. So the one on the upper left here, I mean the lower left, and the other one on the lower right here, those are correct. But the one in between here should be like a regular parabola. But let me take a look at that here, what I got. Oh, I see the reason why. Yeah, it's supposed to be connected all the way up. Because this part right here, it's not considered a slant asymptote in the middle. Just like the horizontal asymptote. If you see the middle part of the graph, so the slant asymptote or the horizontal asymptote does not apply the middle portion of the graph. Okay, so it looks like this one is like a boundary, but somehow this one, the slant asymptotes only shows the end behavior for the left and the right as x goes to negative infinity or x goes to positive infinity. So for this part of the graph, it's just like a parabola. Another thing you can tell that this one, the leading coefficients, positive, positive. So there's no reflection. So that's why the middle portion of the graph, it's like a facing upward parabola. And then determine that the x, the domain and range. So domain for this one, it's negative infinity all the way to the first VA, which is what? -1. And then union, -1 to -1 to 1. No, the first VA, it's negative infinity. Well, that one is -2, so negative infinity to -2. Wait, hold on a second here. Give me 1 sec. So negative infinity to -2, and then union, -2 all the way to 1. Again, because those are the VA, the vertical asymptote, +1. And then union, 1 to infinity. And then for the range, well, the range here, it's hard to tell, okay? Because that's a slant asymptote. Okay, so the range here, there's no need to worry about the range. You can say that the range here, it's all the way from negative infinity to infinity. Because this one, it's just a slant asymptote. It's not the horizontal asymptote. So just define the domain. Okay, so that's it. So make sure that you need to rewind or fast forward. Just watch the video. Watch that as many times as you want, okay? Got to be careful of the detail that I showed, the way to sketch the graph, the way to convert it back to the original parent functions, a over quantity of x minus h plus k, or the one that you have to do the long division to find the slant asymptote. Okay, so thank you for watching it. I'll see you guys next time.